Alright guys, so specifically we're going to be looking at how to do multiplication and division with these things today. So that's basically it. Not much to talk about. There's just know we're going to be talking about multiplying and dividing. So first of all, let's get started with our first note. If you have the square root of a times the square root of b, you can put those two square roots together. So for instance, if I had the square root of 2 times the square root of 3, then that would be the square root of 2 times 3, which is 6.
Can I keep my lunch over there?
Yeah.
Thank you.
All right. I think we'll come back to that note a little bit later. Let me bring up some problems that we'll look at now. All right. So you guys will notice here that we have, okay, guys, I need side conversations to stop. We have numbers that are outside the square roots, and we have numbers that are inside the square roots, okay? So when you're multiplying two things like that, you're going to put the numbers that are outside together by multiplication, and then you're going to put the numbers that are inside together by multiplication. Okay? So you can multiply the outside numbers, you can multiply the inside together, but you're not going to mix them. Okay? So that's the first thing. Now, this number here is going to be negative 10, right? But now for this part here on the inside, you could multiply those together, but I'm going to say let's not, because we're going to have to split them up anyway, right? So let's go ahead and break these things up now. I've got negative 8x, I've got 12x. So first of all, before I begin, I forgot about this. What am I going to do with this little negative here? We're going to cross that off, and we're going to put an I in the front. Okay? That's an imaginary number. So now, let's continue here now. So what makes 8? And what makes 4? And then 12? And then, okay, so I've got, how many 2's do I have there?
2 pairs.
I've got 5 2's altogether, which, yeah, it will be 2 pairs, but I've got 5 2's altogether. I've got 1 3 and 2 x's. Okay, so let's take out some pairs. Here's a mommy turtle and daddy turtle. They go away. Here's another one. Notice I'm putting a dot in between there each time. They go away. And then here's another one. And they go away. I'll bring that back just a sec. There we go. Okay, so let's start with the inside. I think that's easier.
What did you prefer?
12 was 2 and 6, and then 2, 2, 3. All right, so what do I have on the inside here, guys?
6.
I've got a 2 and a 3, which, yeah, we'll multiply those together and we'll get 6. Good. Now on the outside, I've got, what is x times 2 times 2 times negative 10? Negative 40x. Good. So if you're not following that, it's 2 times 2 is 4, right? And 4 times negative 10 is negative 40. So that's where that comes from. You have the x, and we don't want to forget the I that's there also. Okay? So there's that. So that's the end of it. So what did we do? We multiplied the outside numbers. We multiplied the inside numbers. Then we broke it apart like we usually do. Okay? We'll take a look at another example here in un momento. A few pencils moving, so I'll wait for you. You guys giggling about back there so much, Adriana and Brianna. What's so funny? All right. So I'm going to move on to another one. Let's see here. So let's say I have 2 square root of 18 x cubed. We're going to make that 18 a negative times square root of 2x. Make that a negative. I guess we'll put a number out here. Why not? So we'll call this number 2. All right. So I want you guys to tell me what goes in these blanks here. I'm going to ask you there. Michelle, what goes in these first 2 blanks out here? Yep, the 2 numbers that are outside. Stay outside, right? David, what's going to go in here? And how about here? All right. So Adriana, I'm gonna kill this negative here. And what do I need to do instead? Good. You guys see how there's another negative there as well? I'm gonna do it again. Yep. 2 eyes. Matter of fact, I wish I had just done it at the beginning, but it's okay. You can do it this way. All right. So let's see here. So if I were to simplify this, let me ask you what you get there. How about Kimaya? What is 2 times 3 times I times I? What do I get if I multiply all 4 of those together? And since there's 2 i's, it's going to be I squared. Okay, now I'm going to share with you guys something that was on our notes from yesterday. We didn't do anything, not yesterday, Monday. We didn't do anything with this on Monday, but this equals something. I squared equals -1. Okay, so remember on our notes on Monday, I shared with you guys that I is the square root of -1. I squared is -1. And you can kind of think of it like if you squared both sides, the square cancels out the root. That's kind of like what it does. So that's why I have this shirt on my back wall over there. It's a gray one since I squared, so it's keeping it real. Because once you square it, it's not an imaginary number anymore. It becomes a real number, -1. Okay, so we're going to have 6 times -1 there. And what is 6 times -1? Okay. So that was a new thing. We haven't seen that yet. All right. Why don't you guys break down the 18x cubed and the 2x for me, and I'll ask you guys what you got. So take a minute and break those down, and we'll figure out what you guys get in there. let's see what you guys got there. So Edwin, what did you get in the end there?
2 times 3 times x times x times x times 2.
Another 2.
Yeah.
And you don't have to put them together, but I like to. So I'll put the 2's together. So let's see how we got that. Let's see. So 18 is 2 times 9. Well, watch, I'll show you. And then 9 is 3 times 3. And then we have 3 x's. I'm going to put it underneath, though, so that we can kind of see. But yeah. Then down here, we've got a 2 and an x. So I've got a 2, a 3, a 3, a 2, and then I've got 4 x's there all together. So that is correct. We do have 2 2's, 2 3's, and 4 x's. So let's go ahead and take out what we can there. What can we take out, guys? I can take out a 2. What else?
Wait, excuse me?
Yep.
Wait, what if some of us did it a different way, like 6 times 3?
You would still get the same answer. But if you want to see it, I can show you. So the question was, what if we did 6 times 3 instead? So you would have 6 times 3. And then 6 is 2 times 3. And we still have those same 3 x's. So we still have 2 2's, 2 3's, and 4 x's. So it doesn't matter which method you go with. All right, so back to this. So we took out a 2. What else? A 3. What else? An x. And another x. What happens when there's no more numbers on the square root? It's a perfect square, and we don't need the square root anymore. So we just need to put all these together now by multiplication. So go ahead and multiply those together. I'll call on you to see what you guys got. All right, so Shakir, what did you get by putting all those together? Yep. Okay, so I want to review a couple things with you guys on this problem before we leave it. First of all, what we've done so far is we've seen a couple of things. First of all, outside numbers go together outside, inside numbers go together inside. Second of all, every time you have a negative on the inside, you take that out as an I. So I had 2 negatives, so I took out 2 i's. A third thing we saw is that when you have I squared, in other words, when you take out 2 i's, that I squared becomes what? -1, a regular number, a real number. It's not imaginary anymore. After that, you're just breaking it down like we did last time, so there's not a whole lot new going on there. But there's the idea. You guys have any questions or anything about that for you? Yeah?
It's just something. Why do you cancel the numbers when we take them apart?
So that's what square roots do. So like, for instance, the square, you know this, right? What's the square root of 64? 8. And that's because what a square root does is it finds what number times itself. So the answer is 8. Does that make sense? So we're just doing it with a bunch of them at once. All right, so I'm going to throw some practices at you guys here, see how you do. This is student practice 1. All right. 5 square root of 6x, we'll make that a -6x, times, let's say, 3 square root of 3x. And then for a second problem, we'll have All right, so I'll let you guys work on those for a little bit and see how y'all do. We would start by taking the I out, and then we would multiply the 5i and the 3 together, and that would give me 15i. And on the inside, we would have 6x and 3x. Now, whenever you break down your 6x and 3x, you should have gotten a 2, 2 3's, and 2 x's all together, which means we could take out a 3, 2 x's? Okay. And you can take out an x. And so on the outside, I've got x times 3 times 15 times I, which is 45 xi square root 2. Final answer for that guy. All right, number 2. This might have thrown, there's no number here, but that's okay. You can think of it as a 1 if you want, but you don't really need to do that. You can just do 7 times 1 is 7 on the outside. And on the inside, we have 24x squared times negative 6x. And then we take the negatives out. We've got 2 negatives, so I have 2 i's. And so now I've got 7i squared on the outside. On the inside, I've got 24x squared and 6x. Now, 24 would break down into 3 2's and a 3. 6 would break down into another 2 and 3. And we also have 3 x's. Okay? So we could take out a 2. We could take out another 2. We could take out a 3. And we could take out an x. So I've got all these 4 numbers multiplied together makes 84x, and then we have I squared, and then x. And then yes, the I squared, what does that equal?
Negative.
So at negative 1, so if you multiply anything by negative 1, it just becomes negative, and there you go. So that would be your final answer there on number 2. Okay? So that is multiplication. We're going to look at division next. Yes. Before we begin, I'd like to address something else that's a little bit interesting that we'll be using. All right. So, as you guys know, the square root of a times the square root of a can be rewritten as square root of a times square root of, square root of a times a, right? Now, what does that equal? Just a, right? Because for every pair, you can take one out. All right, so here's my point. If you want to get rid of a square root, like let's say I don't want it to be square root of 3. I want it to be just 3. What can we do? You multiply it by itself, and that will make it a normal 3. Square root of a times square root of a is just a, so the square root of 3 times the square root of 3 is just 3. All right, so that's going to be a skill that we're going to use here in this process called rationalizing. Now what I'm going to do is I'm going to give you guys something that looks like this. And it doesn't look like you could do anything with that. But in mathematics, we don't like to have square roots on the bottom. Now, I'm going to give you a little bit of a reason. Do you guys remember what kind of a number this is? Raise your hand if you know. I can give you a bonus point. It's an irrational number. And the one on the top is rational. Okay? Now, we want to have those things separated. And when it's on the bottom, it's not separated in a way that we can work with them nicely. And so mathematicians want to get those out of the bottom. They don't like to leave those there. And the process of getting that square root out of the bottom is called rationalizing. So if a fraction has a square root in the denominator, we need to get that square root out of there, and that's called rationalization. And the way that we do this is in the following way. I don't want this to be square root of 3. I want it to be just 3. So what can I do to turn this into just 3? You multiply it by itself, which you're allowed to do if you also multiply the top. You're allowed to do that with fractions. If you multiply the bottom and the top, that's fine. If you don't know why, do Do you guys know what this equals? What's square root of 3 over square root of 3? 1. What do you get when you multiply something by 1? You get itself. It doesn't change it, right? So what we're going to do is we're going to change the way it looks, but not what it actually equals. So I don't like the square root on the bottom, so I'm going to multiply it by itself. So what will my bottom be now? What's the square root of 3 times square root of 3? It's just 3. The top will be this. Mathematicians like that. Why? Because we can separate that now, and we can work with that in problem with the rational and irrational separated, but we don't like this. So that's called rationalizing it. Okay? So, and we don't like square roots on the bottom, so the way we fix that is we multiply it on the top and bottom. Let's take a look at some examples of that. Example 2. Rationalize each expression. Which means we don't want those square roots on the bottom. I'm going to do 3 examples with you. Let's start with something simpler. Okay, so what don't I like here? I don't like that square root on the bottom. So I can change that from being a square root of 11 to just a normal 11 if I do what? If you multiply it by itself. And I'm allowed to do that if I also multiply it on the top. So 2 times the square root of 11, I can't mix those, but I will put them right next to each other. And the square root of 11 times the square root of 11 is, and now we're happy. We've made our mathematician friends happy there. That's it? Yeah, nice, huh? All right, let's take a look at another one. Square root of 2 over the square root of 7. Do you guys see a difference on this problem?
Yeah,
They're both square roots. That creates a little bit of a difference. Not a whole lot, but a little bit. Which one don't I like? I like the one on the bottom. The one on the top is fine. The one on the bottom, we don't like. So what am I going to multiply by? Multiply by square root of 7, because I want to make the bottom just normal 7. And whatever you do to the bottom, you do the top. So my new bottom will be simply 7. The top, now notice this time, this is where the difference is. Yeah, they're both square roots, right? So I can put these together. What's the square root of 2 times square root of 7? Square root of 14. I got one more example I want to share with you. Number 3. Okay, bonus point. I want a hand up for this one though. What does I equal? I'm still gonna give you a point for that. It's not quite what I'm looking for. There we go. So I want you guys to know that I is the square root of -1. So here's my question to you. Do I have a square root in the bottom?
Yes.
I do. It just doesn't look like it. But I is a square root. It's a square root of a -1. All right. So here we go. I don't like that I down there. So what do I need to multiply it by? You multiply it by itself. You multiply it by itself. Good. So I can do that. But only if I do it on the top also. So what's the top going to be? Well, the top's just going to be 5i. We just put those together. Now the bottom, I'm going to take this in steps, but maybe you'll be able to skip this step later when you get a little bit more used to it. But what is I times I? So you guys are already jumping to it. That's true. It's just -1. I was going to write this first, and then I was going to change it to a -1. But if you guys just want to put -1 there right away, I don't care. That's fine. Yeah. So it's going to be 5i over -3. And we're all done. So that's it. So when you have an I, that is a square root. We don't like it in the bottom, so we do top and bottom. And all that's going to do is it's going to keep the bottom the same, but you're just going to get rid of the I basically, and it's going to become negative instead. That's it. Okay, so that's it for that. Am I good to clear? Yeah, let's do one. Let's see how you guys do. I'll just give you two, and then that'll be it for today. Let's see, square root of 5 over the square root of, let's say, 2, I guess, and then see if you guys can do those two. That was Cal and Lily. That's it. I'll come around and peek at notes again. I would just make that.
Oh, can you read?
Huh? Yeah. Seven I, and then you can simplify it. And then you can actually simplify that or just negative 7.
You pick it up.
Yeah. Yeah. All right. Thank you guys. All right, so I'll put the answers up here for you. Now, a lot of you guys probably put this, and it's not wrong, but a simpler way to write this is, since we're just dividing by -1, anytime you divide a number by -1, the number is just going to be made negative. So I would just write -7i as final answer there. All right, but that's it for today. Don't forget homework is due at 11:59 p.m. tonight, just before midnight. Okay? Uploaded. And I know you might be thinking this has something to do with I just want to
And for my missing notes, what do I do?
just make them up and turn them into Google Classroom. Yeah. So is it obvious that I'm participating today? Yeah?
I don't like group chats like that. I barely got added out.
Yeah, you did really good on that.
Just two that.
Yeah, most people did really well. Yeah.
Oh, we're supposed to take it.
Other than that, my phone is good.
That's good.
That was actually scary. Like that.
I guess I was okay at that.
I forgot about that. Always like
I had that too. I threw that one away yesterday.
Mr. Bailey?
she worked up there, and then so like
Mr. Bailey?
volunteers like they all got like free tickets and shit, but they didn't. There's some like no shows, so like people would flake, and so she just had extra tickets.
I got given yesterday, but I forgot to put it.
Yeah, there's a support center over like in this little room over here.
No, it's over there.
It's up in the front.
You know how that door where you go to the office?
Yeah.
It's the door to the left.
Thank you.
Look, right here is the office to the left.
The office door is straight, but then you go
Yeah,
right.
and then you go to the
The
left.
counselor's office.
Well, the counselor's office is like in the office.
No, like you don't go inside the office.
Oh, it's the door right there. Okay.
You guys can draw a
Because you know how
picture.
there's two doors.
Draw a
You
picture.
know how there's two doors like that.
Yeah.
So this is like the office right here. So like the office door is right here.
It's over
It's like
here.
a little.
No.
So
Listen.
you're going in here, and then you don't go
Okay,
right
wait.
at the door.
Okay, so there's, I think there's two offices. Okay, so there's the attendance office and then there's the counselor's office. Which one is which?
Not the attendance office.
The other office.
Yeah, the student support center.
You don't
Okay.
go inside the door.
Yeah, but you don't go inside the office at all. It's
Okay.
just the. It's
So like,
Just
just
that
the
one
thing
door.
right here.
So like, let's
That
say
one
this is the
door.
door to the office, right? Then there's another door right here, and then a door to the side of the
And there's like
Okay,
computer,
I
and there's
know.
like and there's like computers in there.
Thank y'all.
I was looking for something. I don't have no clothes like that.
Is it okay if I pick that up during lunch?
Yeah, man. Thank you. Alright, we'll see you.
I'm gonna give you a torch.
Stop.